This is Mark Anderson from Kellogg Community College, Math 121, Chapter 2, Section 5, Other Equations of Lines. Now, we learned that the slope-intercept form has, and this is the one that most people are familiar with, and the equation for the slope-intercept form is y equals mx plus b. But we also have another equation to learn that will give us some advantages when we do some work here. And that point slope form is going to be y minus y sub 1 is equal to the slope times x minus x sub 1. Now, what makes these two different is this one is set up by a slope and a y-intercept. And what makes the line on the right a little different is that it has not only a slope, but instead of a y-intercept, it has the point that's here and here. And this new formula to us that we're not as familiar with using is going to give us some huge advantages when we have to find intercepts. So the slope-intercept form is going to be y equals mx plus b, and the point slope form is going to be y minus y sub 1 is equal to m times x sub 1. And I want to move the screen down a little bit and put all of this in the same place here. Alright, so first of all, we are going to try to take the slope of m equals 2 and the point 3, 4 and make that into the slope-intercept form. And this is going to be a review of your previous math class, whether it was taken at KCC or not. And this is going to be the following. Let me turn the color here to blue. All right, so slope-intercept form, y equals mx plus b. Now, what I know is that the slope is 2. So I'm going to plug a 2 in for slope. And my point is going to be, here's my x and y here. So this is my x sub 1 or y sub 1. Make that look like a y. And I'm going to plug that in for my y. So this is 4. I'm going to plug this in for my x, which is 3 plus b. Now, I just need to solve for b to find out what the y-intercept is. So 2 times 3 is 6. Plus b. And then I'm going to subtract the 6 from both sides. So I draw a line there, cross the 6's out. 4 minus 6 is negative 2 equals b. So there's my y-intercept. So this point is 0, negative 2. And my equation is y equals 2x minus 2. Because our slope is 2 from the original equation, and our y-intercept is negative 2. Now let's take a look at the point slope form and see how that's different. The point slope form is y minus y sub 1 is equal to m times the quantity of x minus x sub 1. Now let's plug in what we know. We know the slope is 2, and we know that our point is 3, 4. So we're going to put our 4 here. Notice that this is minus 4, so even though this is a positive 4, it gets subtracted. And over here the same thing. This is 2 minus 3. Now, what we can do with the point slope form is, like, we're technically finished with the point slope form, but what we can do is find the x and y intercept pretty easily. And we practiced finding intercepts in the previous section by putting a 0 and a 0, and we're going to plug a 0 in for my x to find my y-intercept. So y minus 4 is equal to 2, and then 0 minus 3. And if I compact that, I get y minus 4 equals 2 times negative 3. Y minus 4 equals negative 6. And if I add 4 to both sides, y is equal to negative 2. So there is my y-intercept, the same y-intercept we found over here. But you can see where I can now take this information, this point slope form, and find my x-intercept easily by plugging a 0 in for my y. So I'm going to take my y minus 4 equals 2 times x minus 3. I'm going to plug a 0 in for my y. 0 minus 4 equals 2 times x minus 3. 0 minus 4 is negative 4. 2 multiplied by x minus 3 is 2x minus 6. And if I add the 6 to both sides, I get 2 equals 2x. Divide both sides by 2. X is equal to 1. And this will be my x-intercept. So my x-intercept is 1, 0, and my y-intercept is 0, negative 2. So the slope-intercept form is great because it tells you that y-intercept, but it does not tell you the x-intercept. The point-slope form is really nice when you want to find both intercepts. And I think it's important to actually be a little familiar with the point-slope form because you can find points on the line without actually being tied to having a y-intercept in the problem. Let's do the next example here, and it will basically just retrace the steps that I just talked about, except that I'm going to have a fraction instead of a whole number slope. So to repeat the process, let me get my pen started. The slope-intercept form. This is going to be y equals mx plus b. Now, this is our m, our slope, and this is our x, and this is our y, but these are the points, so I'm going to put a little sub 1s there, and that makes this y value negative 4. The slope is 1/2. The x is negative 2 plus b. So, doing our multiplication here, negative 4 is on the left-hand side. 1/2 times a negative 2 is negative 1 plus b. I'm going to add 1 to both sides. The 1 simplified is 0. B is equal to negative 3. So I get my y-intercept of 0, negative 3. So my answer to the line is y equals my slope, 1/2 x from the problem I was received. My slope is 1/2. My y-intercept is minus 3. So there is my slope-intercept form from this slope and point. Now in the point-slope form, let me change this to a different color. Alright, so point-slope. Y minus y sub 1 equals m times x minus x sub 1. Let's plug this in. Y minus y sub 1. So y minus a negative 4. So y minus negative 4 is equal to m times the quantity of x minus negative 2. This means I need to simplify this a little bit. Y plus 4 is equal to my slope of 1/2, I forgot to plug that in right here, times the quantity of x plus 2. There's no reason to kind of simplify that anymore because what I'm going to do is I'm going to use this equation to find my intercepts. Now it's true I already know my y-intercept, but if you weren't actually doing the slope-intercept form, I would like to show you from start to finish how you'd find the y-intercept. The y-intercept would be is if you wanted to plug 0 in for x, this will find your y-intercept, and we know the answer is negative 3. So we're going to have y plus 4 is equal to 1/2 0 plus 2. Y plus 4 is equal to 1/2 0 plus 2, which is 1/2 times 2. Y plus 4 is equal to 1. If I subtract 4 from both sides, y is equal to negative 3. So my y-intercept is negative 3, which we already knew. So 0, negative 3. Now let's go and do another one. Let's go to try to find the x-intercept by plugging a 0 in for y. So plugging a 0 in for y, I now have 0 plus 4 is equal to 1/2 times the quantity of x plus 2. 0 plus 4 is 4, plus, and if I distribute the 1/2 x, 1/2 to the x and 1/2 to the 2, 1/2 times 2 is 1. I'm going to subtract 1 from both sides, that should be a 1. Subtract the 1. The 1 simplify, 3 is equal to 1/2 x. Now, the way to get rid of the 1/2 times the x is to divide by 1/2 or multiply by the reciprocal 2 over 1. 2 over 1 times 3. And these 1/2s will simplify to 1. 1/2 times 2 over 1 is 2 over 2, which simplifies to 1. 2 times 3 is 6. Your intercept is 6, 0. So your x-intercept is going to be 6, 0. Your y-intercept is going to be 0, -3. This is a video that's probably best rewound and played again if you got lost along the way. All right, now we're going to go to the second page here. We're going to talk about parallel. Parallel. Now, the top of the worksheet says parallel, but the instructions say write the slope-intercept equation of the line containing the specific point and parallel to the indicated line. So parallel is important here. So let's get started. How do we do the problem here? Well, see, what I'm trying to do, and as explained in class, I will show you maybe a picture of this, is we want to find out how to parallel to this indicated line. Now, parallel is relative to slope. Two lines that are parallel will never intersect each other, and therefore the slopes are the same. So parallel means same slope. So the m value of one equation equals the m value of the other equation. Now to find the slope, what we have to do is we have to manipulate this equation to look like, well, a slope equation. So we're going to, like in the previous worksheet, we're going to kick the x out. So let's kick him out of the room. And therefore we got -2y is equal to -x plus 3. And then we're going to divide by -2. Now this is going to get our slope. Now our slope here, if we simplify that, we got y equals, now this -1 divided by -2 gives me a positive 1/2 x, and then my y-intercept is going to be a -1.5 or 1.5. But this is what we're looking for. We're looking for our slope, which is 1/2. Now it says, write the slope-intercept equation of the line containing the specified point and parallel to the indicated line. Show all work. So here's what I would do. We now know our slope is 1/2. Since we know our slope is 1/2, we are going to use that to find our y-intercept. And if we were to use just the point-slope form, we'd have y minus r5, see, we're getting that from the point over here, equal to our slope, which is 1/2, and then our x minus 2. This is the point-slope form. Instead of using this equation right here, which has the wrong y-intercept, let's use the point-slope form here. And we're going to now try to find the y-intercept. So, ask yourself, when we found the y-intercept, did we plug a 0 in for the x or the y? To find the y-intercept, we need to plug in a 0 for the x. So we have y minus 5 is equal to 1/2 0 minus 2. This is to find the y-intercept. So y minus 5 is equal to 1/2 times 2. Y minus 5, y minus 5, sorry about the little right-o there, is equal to 1/2 times 2, which is 1. 1/2 of 2 is 1. And then I add the 5 to both sides. Y is equal to 4. So this is my y-intercept. My y-intercept is 0, 4, because it has a slope of 1/2 and a y-intercept of 4. And so our final answer to write an equation that is parallel to this line, and, or actually this line as we write it there, and has the correct y-intercept is 1/2 x plus 4. That's using everything we know. We know right here the point-slope form. We know right here the new y-intercept. And we're going to practice that over here. We're going to do another line that's going to be parallel to this indicated part. So let's go and change colors here so we don't get lost. Okay, step 1. Step 1 is to convert this into slope-intercept form, so we know what we're looking at. So we're going to get rid of the 5x from the left side. We're going to cross that out. Negative 6y is equal to negative 5x plus 4. Then we are going to divide both sides by negative 6 to get rid of the number in front of the y. Those negative 6 get simplified, so y is equal to, my slope is 5/6 x, and my y-intercept of this problem is negative 2/3. Now I want a line that's parallel to this, that goes through this point. We haven't used the point yet, but we're going to use this slope, 5/6. So my slope parallel to 5/6 is 5/6. And since it's parallel to 5/6, what we're going to do is we're going to use that in our point slope form. So y minus, go all the way over here and look at my y value, y minus a negative 4 is equal to my slope, which is 5/6, parenthesis, x minus 3. Now I want to rewrite this a little bit because minus a negative is just plus, so y plus 4 is equal to 5/6 x minus 3. Now to find the y-intercept, do you remember what we plugged a 0 in for? To find the y-intercept, we need to plug a 0 in for the x. So y plus 4 is equal to 5/6 0 minus 3. So therefore, y plus 4 is equal to 5/6 times negative 3. Now, this is going to be a little bit of a weird fraction, because the top times top and bottom times bottom is going to make the numerator negative 15 over 6. But we can do a little cross-canceling or cross-simplifying here. So we can turn this into a 1 by dividing by 3 and turn this into a 2 by dividing by 3. So now I have y plus 4 is equal to, hold on a second here, negative, because that's a negative, negative 5 over 2. Or you can think of it this way, this is going to be negative 2.5. Then we're going to subtract 4 from both sides. I'm running out of room here, so I'm sorry about that. Negative 2.5 minus 4, the y is going to go all the way down to negative 6.5. Now it's okay to have a y-intercept as a fraction, because I'm going to bring it back over here. This y-intercept is going to be negative 0, comma negative 6.5. So 0, comma negative 6.5. So we are going to write our final answer, y equals 5/6 x minus 6.5, or 13 over 2. Negative 13 over 2, if you think of the negative that way. So, a little bit tougher problem because you had this number over here to kind of mess things up. Now I'm going to move the worksheet up just a little bit. Oh, actually, I think I actually have enough room. These last two problems are pretty quick. These last two problems here deal with, what kind of line are we dealing with here? Horizontal or vertical? This is a vertical line. X equals 3. And since it's a vertical line, x equals 3, we've got negative 3 comma 6. Now negative 3 comma 6 is going to be, we want a line that's through these points here that's parallel to this line. So it's going to go parallel through that x value, and that's the way I want to write it there. And going through that x value, this is going to be x equals negative 3. So a line that's parallel to x equals 3, which is parallel to this one, will go through this x equals negative 3. These are parallel lines. More explanation was done in class with this with some pictures, but to do parallel lines, these are both going to be vertical. In this case, this is going to be a horizontal line, y equals 4. And so we look at our y value there and go through that negative 2, So my answer for the parallel line is y equals -2. All right. So with that in mind, I know that was a lot of work there, but let's go and take a look at the perpendicular answers to these problems here. Perpendicular is the same process as parallel, except that perpendicular is going to be straight up and down. I'm sorry, not straight up and down. It's going to be an opposite reciprocal slope. Opposite reciprocal. So when we have perpendicular, take all of your slopes, because they're not going to be the same. Take your slopes, and instead of making them perpendicular, make them opposite reciprocal. Perpendicular is a 90-degree angle. So when you have a slope, you have to take the slope of your first line and make sure it's -1 over m, an opposite reciprocal, to get to that spot. So we're going to start these problems off like we did the last ones. We're going to get the x all by itself. We're going to take that x and move it to the other side. And so we have -2y is equal to -x plus 3. Then we divide everything by -2. Put my little division lines in there. So y is equal to positive 1/2 x minus 1.5, or 3/2. Now you see that this is my slope. But since we want perpendicular to this slope, the opposite reciprocal of 1/2 is -2 over 1, or just -2. So now we have our slope. We can plug that into our y minus -5 is equal to -2 x minus -2. We're getting the 2 and the 2 and the 5 from this point over here. We'll do some swipe to tighten this up a little bit. So my point slope form is y plus 5 equals -2 times x plus 2. Now we can find our y-intercept. We know that our slope is opposite of this -1/2, which is opposite reciprocal of the -1/2, which is -2. And now we just need to find the y-intercept. So we're going to plug a 0 in for y or x. I'm going to plug a 0 in for x, which makes this 2. Now I've shortened this up a little bit. Plugging a 0 in for this, 0 plus 2 is 2. So now I just have y plus 5 equals -4. Subtract the 5 from both sides. Y is equal to -9. So my y-intercept of my new line is 0, -9. It goes through this slope. So this is going to be y equals -2 x minus 9. Now in class, I will show you that this line and this line here are 90-degree lines. And I don't have the equations here to show you that, or don't have the calc here to show you that, or this, I'm not going to take time to do it, but in class you would see where this is true. Alright, moving on to the next part. We're going to do the same thing up above. Let me quickly change to a new color. Okay, so what I'm going to do is I'm going to find out my slope from this standard form. Kick the x out, move it to the other side. -2y is equal to -7x plus 1. Divide both sides by -2. So y is equal to positive 7/2 x minus 1/2. Now, since we want perpendicular, we're not going to use the same slope. We're going to use opposite reciprocal, which is going to be the slope of a tricky one, sorry about that. A slope of, let me just change that, slope of -7/2. Now it's going to make things really funky when I go over to my point over here, because I want a line that goes through these. So here we go. I'm going to go y minus 5 is equal to -7/2, or -3.5. And you may want to think about that as a decimal as we start to manipulate this, multiplied by x minus -4. Now to save time a little bit, I'm going to put down y plus, or x plus 4, because subtracting a -4 makes it plus 4. Now what I need to do is figure out what my y-intercept is. So I'm going to plug a 0 in for x, which is going to be y minus 5 is equal to negative 7 halves. 0 plus 4 is 4. And so now I convert this here. Y minus 5 is equal to, what I can do here is cross out the 2 and the 4, make that a 2 over 1, negative 14. That is a simplification technique called cross simplification. Now we're going to add the 5 to both sides, and you're going to find out that, holy smoke, y is going to be equal to negative 9. And man, there's my y-intercept, 0, negative 9. So my equation, y equals negative 7 halves x minus 9, is the perpendicular, the 90-degree angle to y equals 7 halves x minus 1 half. All right, to finish up this intense worksheet here, we are going to go to these last two problems. Now x here was a vertical line. This is x equals 3. So perpendicular to x equals 3 is going to be a line that goes left to right. And since lines that go left to right are always given as y equals, this is going to be y equals 6. Now this over here is going to be a horizontal line. This is y equals 4. And since perpendicular is vertical, the perpendicular line is going to be x equals 5. So perpendicular means 90-degree difference, so this is y equals 4. The perpendicular line to that is x equals 5, and it goes through that point. The horizontal line, or the vertical line, is x equals 3, and the horizontal line would be y equals 6. And more examples like this were given in class. So please email me your questions. This is a very challenging section, so I appreciate you for watching the video today. Thank you.